Welcome to another video of Edifo. Selection of hypothesis test method is a critical stage in any social research process. Today in this video, I am going to demonstrate the difference between parametric and non-parametric tests. So, let's begin. Parametric and non-parametric are two broad classifications of inferential statistics procedure. Or we can say that statistics can be categorized into parametric and non-parametric statistics. The selection of statistical test purely depends on the hypothesis you need to prove. If there is no hypothesis, then there is no need for statistical tests. All statistical tests are derived based on some assumptions about your data. We are all conducting research with an aim of a goal, that is to discover some truth about the population and what is the effect of an intervention on that population. It is usually impossible to collect data from all individuals of interest in a population. So, our only solution is to collect data from the subset of population that is called the sample. From this sample, we can find some quantities of population, that is mean, standard deviation, or we can say some proportions on the basis of some attributes. These are all very important in case of a population as general. So these quantities are called parameters. So the parameters about the population is derived from the sample. So we are taking sample from the population for finding the parameters of the population. All these parameters are just an estimation. So, using sample, we are estimate the parameters about the population. But important thing is that we are find the parameters about the population using the sample. We are only takes the data of sample and we find these parameters. So, if you are find the parameters from the sample, that is called statistic. So, we can say that statistic estimates parameters, or sample is used to estimate the parameters of the population. So, parametric statistical procedure assumes that the sample distribution is about the same shape and has the same parameters as the general population distribution. It is an assumption. So if we find the parameter from the sample, we assume that all these parameters that we estimate from the sample is equal to the parameters of the population. A parameter is the characteristic of the population, or we can say it is an aspect of the population. For example, a mean of the population is a parameter, or we can say the standard deviation of the population is a parameter. So these are all parameters. So we can say that the parameter is an assumption about the population, but the statistic is an assumption about the sample. And we are all estimating the parameters of the population using the sample statistic. That's why we earlier discussed about that. The statistic estimates the parameters. So, the parametric statistical test is one that makes assumptions about the population parameters from which one's data are drawn. These parameters are, for example, mean, standard deviation or proportion, etc. On this basis of assumption, The distribution is very important. A population distribution is assumed to be normal. So, the nature of distribution of the data should be normal. Parametric statistics are any statistical tests based on underlying assumptions about data distribution. In other words, parametric statistics are based on the parameters of the normal curve. That is, mean of the normal curve, standard deviation of the normal curve, the proportion of the normal curve, etc. So, parametric tests rely on the assumption that the data you are testing resembles a particular distribution. Here it is normal distribution, or we can say a bell-shaped distribution. In the parametric test, the assumption is made through the sample population. If the information about the population from which the sample has been drawn is completely known through its parameters, then the test is called parametric test. But in the case of non-parametric test, as the name suggests, there is no assumption about the population. The non-parametric tests are also called distribution-free tests because there is no strict assumptions to check in regard to the distribution of the data. Non-parametric statistics are not based on the parameters of the normal curve. That means the distribution is skewed. You can use non-parametric tests. Next, assumptions of parametric test. Usually, the parametric tests are known to be associated with strict assumptions about the underlying population distribution. But one thing is very important: the different parametric tests have different assumptions. Here, I would like to explain some common assumptions of parametric tests. Then you can understand where we can apply parametric and where we can apply non-parametric tests to prove your hypothesis. So, this is the first assumption, that is assumption of normality. This is a prime assumption of parametric test. Most of the parametric test requires that the assumption of normality be met. Normality means that the distribution of the test is normally distributed, and you should make sure that your data roughly fits a bell curve sample before running a parametric statistical test. Here you can see this graph is normally distributed. Then you can apply a parametric test. So before conducting a parametric test, you should make sure that the data you have collected is normally distributed. Here you can see this is a skewed distribution. You can't apply a parametric test, the data distributed like this. So, if the data is not normally distributed, that is, the data is skewed like this graph, you can select a non-parametric test. The core element of the assumption of normality asserts that the distribution of sample mean is normal. In technical terms, the assumption of normality claims that the sampling distribution of the mean is normal, or that the distribution of means across samples is normal. To test the assumption of normality, we can use Shapiro-Wilkes test or Kolmogorov-Smirnov test, etc. You can apply these non-parametric tests. You can make sure that your data is normally distributed. The second important common assumption is homogeneity of variance. Homogeneity of variance means data from multiple groups have the same variance. That is, the population variance of two or more samples are considered equal. For testing the homogeneity of variance, you can use Levin's test. Levin's test is commonly used to assess if the groups have equal variance. The third assumption is interval or ratio level measurement. In a parametric test, the data should be in the interval or ratio scale. If you are using SPSS, the interval and ratio are measured in interval scale. But in the case of non-parametric test, the data may be in nominal or ordinal scale. That means you can apply quantitative data in parametric test and apply qualitative data in the non-parametric test. So prefer quantitative data if you are going to apply parametric test for prove your hypothesis. Nominal and ordinal scale data normally considered as qualitative data. For example, gender, department, religion, demographic region, etc. are nominal in nature, so they are the representations of some qualities of the respondents. So if you are collecting qualitative data, you prefer a non-parametric test. If you are collecting data in interval or ratio scale, they are in quantitative nature, then you can apply parametric test. The next assumption is independence. Data point values for variables for different groups should be independent of each other. This is a commonly applicable assumption for almost all parametric tests. Next is nature of analysis. If you want to compare the parameters of the data, that is mean of the data or standard deviation of the data, if you want to compare these, then you can apply parametric test. And if you are going to compare the proportions or percentages of the data that you are derived from nominal or rank data, then you can use non-parametric test. So these are the very common applicable assumptions of parametric test. By understanding these assumptions, you can get an idea about which test that I can apply for prove my hypothesis. In some situations, we need to find some non-parametric alternative of parametric test. So here I'm going to explain some non-parametric equivalence of parametric test. The one sample t-test is a parametric, its corresponding non-parametric test is sign test. So if the assumptions are not met, you can apply the non-parametric test. The second is t-test for two independent sample. So two independent sample t-test, its equivalent non-parametric test is Wilcoxon-Rank-Sum test. So if the assumptions of t-test is not met, you can apply Wilcoxon-Rank-Sum test. The next is two sample t-test. It's a very popular test. So its corresponding non-parametric test is Mann-Whitney U-test. The next is two sample t-test paired, or they can say paired two sample t-test. Its corresponding non-parametric test is Wilcoxon signed ranks test. The next is one-way ANOVA, very popular parametric test, and its corresponding non-parametric test is Kruskal-Wallis test, or you can apply Moore's median test. The next parametric test is two-way ANOVA. Its corresponding non-parametric test is Friedman test. The next is Pearson correlation. It is a parametric test. Its corresponding non-parametric is Spearman rank coefficient test. So these are the different parametric and its corresponding non-parametric tests. So in conclusion, we need to remember the following points. The first one is parametric and non-parametric are two broad classifications of inferential statistics test procedures. Parametric tests are based on assumptions about the distribution of data of the underlying population from which the sample was taken. We are taking the sample and we estimate the parameter using the statistic. Next, parametric tests do not have assumptions about the parameters of the underlying population distribution because there is no hard and cut and rule assumptions about the population in non-parametric test. Next, if you are using the parametric test, even in the case of deviation from the assumptions of the underlying population distribution, then you could lead to incorrect conclusion. If your data are not met the assumptions of parametric test, even though you are applying the parametric test, definitely you could lead to incorrect conclusions. So finally we can say parametric tests are very powerful and non-parametric tests are not that much powerful. I hope this will be helpful for you. Please share this video and I expect your comments in the comment section below. If you are not subscribed my channel, please subscribe my channel and press that bell icon for future updates. Thank you. See you on next video.